Okay, so welcome back to the shop. It's been the first video for a while, mainly because basically it's been a pile of the same, and there's only so much shaft machining that I can show before everyone gets bored. There's quite a few new subscribers, which is great. So I thought I'd cover something that I covered previously, probably about 2 years ago, right in the one of the very first videos that I did. But this is part of the Joys of the Job Shop series, and we've had a little fabrication job come in, which has got some basic development, but it's interesting, and you know it may serve a purpose if you're not very familiar, if you're into fabrication but not very familiar with development. It's certainly worth looking into and getting a grasp of. So here's the hang on, I need to fold it a minute so we can't see any of the important information. Right, so let me just make sure I'm in I can put it that way. That's a little bit awkward. Alright, that'll do. Right, okay, so here we got a squared around transformer. It's made from 3mm or 1/8 inch thick stainless steel. It's not the biggest. It's only 156mm square with a 70mm ID on the round end, and it's 67mm tall. So it's not the biggest squared around you're ever going to see, which, especially with this this wall thickness, can pose a little bit of a problem when you get down into these corners here. But we got a little trick that we're going to show to get these right. Partly, I think this has come from it's either SolidWorks or maybe it's an Inventor drawing, and it's I think what Inventor and both SolidWorks do is they can calculate a standard inside radius for a certain thickness of plate, but it assumes that you are bending that plate 90 degrees, which obviously here we're not. It's a series of folds, although it appears to be 90 degrees from the plan view. It's just a series of small folds. What's going to happen is we're going to gather up in this corner here, and if we're not careful, we're going to end up with a big radius. Pardon. Okay, so the first thing we need to do is we need to produce a plan view, and we need to produce an elevation. Since this is an equal squared around, we only need to produce one corner because that then repeats. But first thing we need to do is figure out the dimensions that we need to draw our development plan to. So the two main dimensions that we're concerned about as far as the plan view is concerned is this 156mm. Now obviously this is an outside dimension, and whenever we fold plate, we need to subtract the thickness. So get the top off my pen here. So we're going to be looking at 150 by 150, because we've got 3mm this side of plate and 3mm that side. The next one for our plan view is this 70mm inside diameter, and this is slightly different because we need to treat this edge as if it's rolled. Now the difference between when we roll a plate and when we fold a plate, when we fold a plate there, we always work to this inside dimension. When we roll a plate, we have an inside diameter, an outside diameter, and through the middle we have a mean diameter, or an average diameter. So in this case, they're giving us an inside diameter, so the mean diameter is equal to the inside diameter plus wall thickness. Yeah, so we don't add two thicknesses here, we only add the one. Obviously, if we were given a outside diameter, it would be minus wall thickness. Okay, so we need to add 3mm to this, so our plan will be drawn with a 73mm circle, diameter circle. Okay, the other dimension that we need to use is this 67 millimeters, which is the total height. Now, like I said just a minute ago, with this particular one, because it's equal, each corner is equal, just to speed up the process, we only need to produce dimensions for one corner and then basically repeat it. If we had a rectangular transformer, then we'd only need to produce half a pattern. The only reason usually that you need to produce a whole pattern is if you've got something along the lines of an offset squared around, so you have the bottom there and that goes up, and this is perhaps at I don't know, 22.5 degrees, something like that, in which case then and obviously rectangular bottom, you'd need to produce the whole pattern then, because of the different heights. Okay, right, I'll set up with some development paper now and some marking out tools, and we'll get on with it. Okay, so we got our development paper. I say development paper, but it's not. It's actually it's electrical insulator sheet. It's I have mentioned it before. It's basically very, very thin, flexible fiberglass sheet. But this is oil proof and it's chemical proof, and pretty much heat proof. Sorry, miles away. Yes, with it's chemical proof, oil proof, heat proof. I put some blue on there just to hopefully show up on the camera a little bit better. But yeah, I find it very good for marking out. You can cut it with scissors or tin snips, and you can file it, and you can fold it if you need to, in a box and palm folder, or score it and fold it, so you can get a good idea of where your shape's going before you actually put it on the sheet. We could mark this directly onto the plate, but as being as it's stainless, and it's got to look pretty. I don't really want I want to have to blue it all up, and I don't want scribe marks in it, so we're gonna mark it out on this and then transfer it, and then we've always got the pattern then if the job ever happens to come up again. I probably should have this pattern somewhere because I did one identical last year. So right, let's get on. It's a little bit awkward because I'm sort of working over the camera here, so we'll have to see how it goes. Okay, so the first thing that I'm going to do is I'm going to put let's make sure I'm in. Yeah, okay, right. I'm going to put a vertical line in here. It doesn't matter at the moment. Oh, this is just a. Oh, that's showing up. Okay, so this is just a scribe, and we've also got our dividers out and a rule. Okay, you don't need two sets of dividers, but it does come in handy, and I'll show you why. Now, right. So the first thing we're going to do is we're going to set our dividers at 36.5. Yeah, so that's half of our 73. I like to start at if I'm start at the 100, and then I know that I got a good zero. Okay, so I'm just going to pick a point anywhere along this this vertical line and scribe that circle. I'm drawing half a circle just for a minute because I need to bring a line perpendicular to this this vertical line off there. So all I'm doing now is I'm just going to set my dividers to anything. Doesn't really matter. Come off this point and bisect the circle. Okay. So mark a line through now from the center point of the circle we scribed to the cross. Make sure we got enough. Okay. What I'm going to do now is I'm going to put a line parallel to that. 67 mil, which is our height. So I'm going to set my dividers at 67 mil, starting from the 100 again, and I can feel the little groove in there. So all I'm doing now is feeling for the other one. There we go. Okay, and we'll see what this this line is for now in a minute. All we need to know is that this is set at our height. Yeah, doesn't need to be that long. Okay, so next thing we're going to do is we're going to mark off here at half of our 150 mil, and then we're going to mark off here at half of our 150 mil. I'm going to do it with my dividers because they happen to be out. So 75, I'm feeling for the little groove, there it is. Okay, now what I'm going to do is I'm going to come off this, mark there, come off this one, mark there, and now I know I'm square and true to the world. Okay, can we see that? Yeah, right, great. Okay, next thing we need to do, obviously now we've got a quarter I've out squared around. We're just going to check that we are where we said we are. Yeah, we're 75 there, 75 there, 75 there, 75 there. We need to make sure that we're square, and a simple way of making sure that we're square is if we take our dividers and go across the corners. There. We should cross the corner that way. There we go. So we know that's square and parallel, and we're good to go. Next thing we need to do now is divide the circle up into I don't know, probably ideally we want our folds to be sort of about 1/2 inch or 12 millimeters apart. So I'm guessing that probably about 6 would do it. And the way I'm going to do that is I'm going to set up at the radius there. I scribe line that way, and I'm going to set up. I move my dividers, set it this way. I'm going to divide it into 3 very, very quickly. Pardon me. Now what I could do is, if I wanted to, I could bisect this to get a point between them, which would give me my 6, or at least give me a start. Right. And I'm going to step it out there. Okay. Just slightly. Not the sharpest dividers in the world, yeah. Okay, but that looks good to me. Are we going to reach the next one? Slightly under. Okay. There. There. Oh, there we are. And there we go. So we've ended on the end there. It's important to get this measurement as close as you can, and the main reason is that we've got 24 divisions, so potentially we could run out quite a lot. Actually, we only got 12 because we're going to do it in 2 halves. But potentially we could run out quite a lot if we were 0.1 of a mil out. We'd end up over a millimeter out on our circumference. So this is the reason that I use 2 dividers. That's set now. I know it's right. I can pull them to the side, and they're set for when I need them. Right. Okay. Next bit now is we're going to scribe these lines across into the corner, and then we can start getting some true lengths. Okay, right. The beauty with this is that when you mark it, it does create a little bit of an indentation, so you can feel it as you scribe across. You can feel him just drop in there. And one more. Okay, the next thing we need to do is we need to number them. We're going to treat this. Let's see if I can Let's move it just a bit. So no, that's worse. A lot of glare there for some reason. I don't know why. Right, we're going to treat it like a map, and so as we don't get lost, we need to have some reference of where we are going. Okay, so it's good practice to get into, even if you sort of do remember, because because we have a central one, these three are the same as M3, you know, and so it's only the middle one. Once you've done, once you've come across there, you know, you're just repeating the pattern again. It's good practice to get into it, because when you start doing more complex development, you know, you're gonna have a hell of a lot of lines all over your sheet, and you're gonna forget where it is that you're going. So I like to do it this way. I like to come around the outside with letters. Can you see it? Yeah, so we got A, B, and C, and then starting at this corner, 0, 1, 2, 3, 4, 5, 6, and then 7 and 5, 8, 9, 10, 11 and 12. Okay, right, so there probably should done actually, I'll tell you what, no, that's fine, that works fine. You can, if you want, have 6 and 7 as the same, and use 0 as a 0, but it doesn't matter in this case. Okay, so just 2 minutes, just to sort of cover true lengths, which is why we have this plan view, why we have this this, it's not an elevation, but it represents the total height of the part. Now, if you think of it like you have a wall. Can you see that? Yeah. So here's your wall, right? And here's the ground. This wall is I don't know, 2 meters tall, right? And we need to get a ladder to the top of it, right? But obviously we can't put our ladder straight up our wall because it's going to fall over, so we need to budget out a bit, right? Okay, so what we know is, we know our height, which is here. So this is our height, this is our total height of the part here. And we know, so that's height. And we know our plan length. So I'll put that as PL. So these are our plan lengths. So we're looking down on a part, and if we measure from it there in 2 dimensions, that gives us plan length. This then would be our true length. So that's the actual length of the this side. And the way that we're going to do that is we're going to take, oh, fucking bollocks. Now why did I put them to the side? Because I didn't want to lose that dimension, did I? Fuck. Right, okay, so oh god, right. This is why everything that you try and video, just it takes, you know, an hour's job takes 3 bloody hours, right? Right, so so we got a height already marked here between these 2 lines. So we're going to take our plan length, because we know it. We'll just pick one. So we'll pick A to 0 as our first plan length to mark off. we're going to come from this point, scribe a line. Now if we put our divider across there, up to that point, because remember this is our 67mm here, that then gives us the true length of this side, so it's going to be sort of up on that angle when it stood up. Okay, so that's what true length is about, and that's the reason that we need a plan view and an elevation. All right, obviously if this was a offset squared around, can you see that? Yeah, if this was an offset squared around, what we would do is we would draw our elevation, scribe our arc round there, divide it up, same as we did. We bring these lines down perpendicular to the face, and then we bring them from these points down. Perpendicular to the base, and that would then give us our elevations for each point. Okay, yep. So well, it's a little bit more advanced, so perhaps if I get another one in, we can have a look at that. Right, so right, how much memory have I got? Okay, right, so I'll just take you through the first couple of steps here, because I'm running out of memory slowly, and then that'll probably be it for this video, and we'll come back on another video and we will make it. Right, so I'm just going to draw a baseline here, and I got to make sure that it is greater than 150mm, which is my length. Remember, although I only drew a quarter of it, I'm going to work off both sides of a center line here to make it quicker and mark off both sides at the same time. Okay, so right, I'm going to mark off my 0, and I'm going to mark off at 150, and I'm going to mark off at my center at 75. Just leave them bloody dividers alone. Right, I need to bisect that then to get a center line perpendicular to my base. So I'm setting my dividers at anything, doesn't matter. Scribe a line that way off that point, scribe a line that way off that point, and bring my line through there. Okay, right, now in relation to where we are on here, right, this is A, right, this is B, and this up here is 0 and 12. Okay, well, you'll see now. Right, so the first thing we need to mark off is the true height of A to 0, which we happen to have already done. Okay, so there. Okay, right, next we need our circumference. Let's check I'm still in the right place. Okay. So I'm going to mark one off our way and one off our way. Forget about this side at the moment because I'm just doubling up so that I get the whole pattern. But technically here I'm marking from 0 to 1. Okay, so 0 to 1. So technically that is 1. Yeah. So I need, next one I need is B to 1. Or what I could do is I could do a bit of an idiot check here and do B to 0, and it should end up there. Should we do that? Right, okay. Oh, for fucking hell. I give up. Fucking give up. Did it again. Right. Okay, so B to 0, and I should. Oh, for fuck. Okay, I'm sorry. I'm just not fucking with it. Yeah. Right. Again, we've taken our plan length. Mark it off there. Okay, and I should cross the. There we go. Yeah, okay, so I'm picking up there. Right, so we know that's right. Alright, next one I need is B to 1. Mark them off here. And pick up from there. Take it out true length. Okay. And we're going to scribe through there. I'm just going to come this side and do this one as well. Okay, right. Next one we need now is B to 2. Now it's up to you, you can come off here now. In fact, I might do. Let's do it in a specific order. Right, I got 3 minutes of memory here, so right, again I'm going to pick up my circumference. Okay, that's good. Right, so I'm going to come from where they intersect, scribe line. Okay, that side. That side. Okay, now I want B to 2. Again, mark it off. Okay, B to 2. There. Okay, so that's 2. Okay, the next one's going to be 3. So I'm going to scribe line there. Remember, this one hasn't changed. Or it's not supposed to. It's changed 3 times so far, but it's not supposed to have. That one just goes over there, and we this is just used for marking off our circumference. Okay, right, so next one I need is B to 3. Right, and if I mark these, which is 3, 2, 1, and 0, right, so that's B2, and that's 0, 8 to 0. Okay, what we can see is that 0, 1, and 2 are the same as 6, 5 and 4, 7 and 8 and 12, 11 and 10. Okay, so this is all I need now as far as true length calculations are concerned. Right, so I get my B3. And intersect that line. Just gonna make sure. Okay, right. I'll bring you back in a minute and we'll have a look at the rest of it. Okay? Oh, hang on a minute. Where's my... Oh, no. Right. See you in a minute. Okay, right. So here we are. Back again. I got another 10 minutes of memory before it runs out, but I should see it for this video. Okay, so what I said earlier was that that 0, 1, 2, 4, 5 and 6, they're the same. So we don't need to add any more. Oh, I'm out of shot. Why is that? There. So I don't need to add any more dimensions to here. I can just keep working off these. So I'll fly through this now as quickly as I can, and we can get to actually making it look like a squared around. Okay, right. I'm not going to talk too much because I need to get this job done today. Obviously it's not worth a whole pile of money, so I need to get through it as quickly as I possibly can. And this is why the numbers are important, because you know we're starting to get quite a lot of lines on here now, so we're going to start to forget which ones we've done, which ones we haven't, you know, and stuff like that. Six. Okay, so that's those 6 divisions there. I numbered them 1 to 6, and then you saw me go back along to 12. Now, technically, if I started here 6, 7, 8, 9, I'd get to 12, and that would be half a pattern. But you get the idea. Okay, so that's those 6 divisions for circumference, and we marked them off our side as well, and that's basically now half of our circumference. Next thing we need to do is we need this distance, yeah, but as it happens we're only doing half, because that's going to be a split line there, and there's going to be a split line there. So we need to go from B to C now. I'm going to take it direct from our plan view. Okay, I'm going to scribe it off, scribe an arc there. Next one we need is 6 to C, but 6 to C is the same as 0 to A, yeah, because they're identical. Again, it would be different if it was this type, but as it happens, we've already got it here. Remember, this is a true length again, and we're going to come from 6 I'm going to mark off there. Forgot to do this side. Okay, there. Here's my time looking. Okay, we're doing good. Just swing this over to this side. There we go. And now it's just a case of joining the dots. Okay. Huh, no good blowing the camera, is it? Okay. Now from there. Yeah. Okay, now all we need to do is basically we're going to join these up to start off with a roll. Now when we cut it, we will add a little bit of artistic flair to smooth out the radiuses. God, this is all good with this camera. God, I can't see a bloody thing. Where am I? It's a real awkward way of doing it, because I normally work the other side of the roll, but the camera's in the way. Okay, done that. Right, now here's something. Oh, hang on. Let's put these lines in. These are going to be our bend lines, and they're all going to come down to this corner. Remember that we need to try and keep the radius, well, virtually non-existent there. And I'll show you how we're going to do that now. Breaking camera. Right, let me come aside. Okay, there. 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 Okay, right. So there's our basic pattern, right? Something that we must not forget here. Remember now, this is reasonably thick plate for this sort of size. All right, let's just do a bit of an idiot check a minute, just to make sure that we are, yeah, 150 should be 75. Yeah, okay, right, with the right size. Right, so this is 3mm thick, so we got a fair bit of bending to do. Now, if I was to transfer this to plate and cut it here, I wouldn't be able to get this fold. Right, that wouldn't fold clean there. So what I need to do is I need to add material to here, so I can do this fold. Yeah. If you imagine the jaws of the, oh, this is going to be there's the bed of the folder. Here's the jaw that does the fold in. It's not bad actually, right? If that's out here, it's not going to even, I'm going to have a nasty looking edge. So I need this little bit extra to get that last fold in there. And then what we'll do is we'll cut this off afterwards. Right. I'm just going to pause you a second. Okay, right. So what I'm going to do is I'm going to drill through it just by so that I can prick punch it when I transfer it to sheet, because otherwise it's going to be very difficult to be able to transfer these fold lines without stepping out that circumference. I know all I need to do is just I can prick punch through there, and I know I just need to propagate in this corner. So oh right, yeah, what we're going to do is I'm going to put a little mark on this central fold there that I can punch into the sheet. And what we're going to do is we're going to split the sheet about 1/2 inch long up here, and that will allow us to fold that corner with a nice tight radius. Right, I'm going to get this cut out off camera a second, because I'm pretty short on memory, and then we'll have a look at our pattern and where we go from there. Okay, so back away. Hang on. So this is our pattern. Like I said, it's real easy to sand, so we can get that radius right down on that stride line, and nice and smooth. Okay. Okay, so there we go. Oh, just to show where we're going. That's where we're going to split our plate, so that we can get these corners to fold. Okay, so that's pretty much it. I think next video now we'll come back and we'll turn this into a piece of plate. I'll see you next time.